the valley on their vertices and draw the asymptotes where I cross the midline. Let me show you another example. Let's look at secant. We know that secant is the reciprocal of the cosine. So what I'm going to do is I'm going to draw the cosine first. Knowing that the cosine has a period of 2 pi, and has an amplitude of 1 normally, what I'm going to do is put my cosine graph here first, based on what I learned yesterday, and draw that cosine graph. And then, like the cosecant, the secant will flip the mountains and the valleys and draw the asymptotes where you cross the midline. What that means in this case is the following. The purple is the secant graph. With the asymptotes occurring where my cosine graph was crossing the midline. On the exam, I'll be looking to see your cosine graph, the flipping and 1 full period of the secant graph, and the asymptotes. Let's look at trying some more complicated problems. Let's look at A. In A, we see that we have the cosecant. Cosecant is the reciprocal of sine. So when I see this graph, I'm thinking, let's look at the sine. So when I look at the sine, there's some things I need to know. First of all, what about the amplitude?
Doesn't change.
Wrong.
2.
2. It's the number in front of the cosecant. What about the midline? It's not nothing. It's 0. Because it's the x-axis. The period has been affected. There is a number directly in front of the x. So I'm going twice as fast, so my period's half as big, which means my period is pi. Algebraically, the way that you can find it is go 2 pi divided by the 2, that's pi. And has it been shifted at all? No. So I write down none. There's no phase shift. So when I'm doing this graph, I want to keep in mind that my period is no longer 2 pi, it's pi. So here's what I do. On my axis, I go to the end, and instead of writing a 2 pi, I write pi, because that's the period. And then halfway would be pi over 2, a fourth of the way would be pi over 4, and 3/4 of the way would be 3/4 pi, or 3 pi over 4. And this was the sine graph, but now I have an amplitude of 2. So I need to go 1, 2. And then I'm going to graph this like this was a sine graph. So I graphed the sine graph.
Please excuse the interruption.
So I'm now going to graph this sine graph in a different color so you can kind of see what it looks like. So let's say I was doing this y equals sine graph based on what I saw in the red. If I were to do that, I know the sine starts at the midline because I haven't gone up or down. That means I'm at 0. My amplitude is 2, so that means I go 2 high, back to the midline, 2 low, and then back to the midline. So this is my sine graph. Why am I looking at the sine? Because that's the reciprocal of the cosecant. Don't draw for a while, just watch and listen. I'll give you time to draw. So in this picture, what you see is that I've taken into account that my period is now pi. I have my midline still on the x-axis because there was no shift up or down with a plus or minus outside of some kind of parentheses. Notice that my mountains are 2 units above the midline. My valleys are 2 units below the midline. That's because there was a 2 way out in front of the cosecant. The period is pi because of the 2 in front of the x. All I have to do now is draw asymptotes wherever I'm crossing the midline. So asymptote on the y-axis, asymptote at pi over 2, asymptote at pi, and then to draw my cosecant graph, flip the mountain into a valley, flip the valley into a mountain, and in the hot pink, this is the graph of 2 cosecant 2x. This one is the secant graph, and the secant graph is the reciprocal of cosine. So when I think about this graph, I'm going to be thinking about the cosine graph. And I noticed that in this cosine graph, if I was ignoring the SEC part, and I thought about it as just the cosine word in there, I know that my amplitude is going to be, no,
3.
it is 3. But if you would like to write down flip, that's fine, but the amplitude is 3. If you write down -3 on the test, I'm marking it wrong, I record it in the chat, prove it to your parents. Don't write negative. Amplitudes aren't negative, even though it is flipped. Your midline, did that change? So that's 0. Your period has changed though. Instead of being 2 pi, it's pi. Because I'm going twice as fast, the number in front of the x, that takes me half as long, it's pi. Was there a phase shift?
No.
No, there's none. So I have to draw a cosine graph that is an amplitude of 3, period of pi, and has flipped upside down. Stop writing and watch. Normal period was 2 pi. I am now actually only going to be at pi. So just like the previous graph, I have the same markings. This time, though, my amplitude is not 2, it's 3. And because of that, I also know that I am flipped. And so in the cosine graph, when I graph that, normally I would start my mountain at 3. But because it is flipped, I'm going to go to -3. And then come to the midline. And then go the opposite direction from the midline. Then come back to the midline, and then come to the minimum or maximum, whichever way you want to think about it, value. And here is a cosine graph with an amplitude of 3 that has been flipped upside down. After I flip it, the thing to remember is you always put your asymptotes wherever you see the graph crossing the midline. So when I look at this, I see this cosine graph crossing the midline at pi over 4 and 3 pi over 4. And then to do my final graph, I take this cosine graph and I flip the valleys into mountains. I flip the mountains into valleys. And what I will see is in this orange graph, I have the graph of -3 secant of 2x. Is the reciprocal of sine. So in my brain, the first thing I think about is all I'm going to talk about is the sine graph. Then off to the side, I'm going to talk about all the things that happen to that sine graph that I'm going to be flipping later. So for example, I'm going to talk about the amplitude. Is there a change in the amplitude?
Yes.
Yes, it is
2.
2. And was there a change in the midline?
Yes.
Yes, it's also at
2.
2. Did the period change?
No.
No. So the period is
2 pi.
There's a lot of 2's in this sucker. And there's a phase shift of
-pi over 4.
okay. How many people got all 4 of those? That's 4 out of 5 or 6 points or 7 points right away. Good job.
Yeah.
So if you get those 4, you can like leave this blank and you already got 4 points for that problem. Okay, that's a good deal. You're welcome. So now I know. Alright, back to our problem. The first thing I'm going to take care of is the midline. So as I mark up my graph, what just happened?
You just pulled it down.
I don't really know how that happened. Okay, so my midline is at 2. So 1, 2. Here's my midline. Remember, everything is going to be based off of that midline. And then, normally, my period is 2 pi, and it didn't change. So if I were marking this up, I would have put 2 pi here, pi over 2, and 3 pi over 2. But there's a problem, right? The problem is my graph has been shifted to the left, pi over 4. So now instead of these black marks, I have to make new markings. Markings that indicate where my new critical values will be. And instead of being on these black marks, they're going to be to the left, pi over 4. Okay, just so you know. To the left, pi over 4. So normally, I would have a mark here, and here, and here, and here, and here, somewhere on the graph. But everything's going to be shifted over. So I'm going to indicate that by putting a little tick mark, and I know that I said pi over 4. So all I'm going to do is I'm going to write down a mark that's a little bit to the left of 2 pi, roughly pi over 4 over there. Okay, yeah, it is. I'll go exactly in between if that's where you want it, because that's where it is. So that's fine. Here. Right there, right there, right there, right there, and right there. Taylor Tate. What is the location of that purple mark? I'll give you a hint. It's pi over 4 to the left of 2 pi. It is not 3 pi over 4, which is to the left of pi. Who knows? Adam.
It's 7 pi over 4.
That is correct. 7 pi over 4. Because 2 pi is the same as 8 pi over 4. Take 1 pi over 4 off. If I move over a little bit more, pi over 4 more than pi would be 5 pi over 4. Do you notice a pattern here? Oh, the next one would be 3 pi over 4. And then pi over 4. And then negative pi over 4. And are you saying the O because I look so good, or are you doing about the purple stuff?
You're good.
Yes!
Good.
I'm going to make you write them down on the test. Because you should be able to add or subtract pi over 4. So now I'm going to graph this thing. Because I know that everything occurs with the midline. I know it's really like a sine graph. And I've moved everything over. Now I just have to be careful to know that from my midline, I'm going to be going up and down 2 units. So here's my midline. My sine graph starts on the midline. It hasn't been flipped. So it starts right here. Because I've shifted to the left pi over 4. And then it goes up to its maximum amplitude on the next critical value, which is at pi over 4. Then it comes back down to the midline. Then it goes below the midline. Don't ask questions right now, thank you. And then it goes back up to the midline. And this would be my sine graph that includes my midline at 2, an amplitude of 2, and a phase shift of pi over 4 to the left, or in other words, negative pi over 4.
All I had was
Okay, then the last steps, of course, you need to put in your asymptotes. So the asymptotes occur where your graph is crossing the midline, which is here, here, and here. And then, of course, we haven't even drawn our final graph. We have to draw the final graph. My final graph will be the flipping of my mountain and my valley. So the final graph is in the hot pink. The end.